What if you could make Python do math the same way you think about it? Add, subtract, multiply, calculate shopping totals, or evaluate formulas, all from code. In earlier lessons you learned how Python stores data and how it speaks using text. Now we give Python the power to calculate with numbers. You will discover how Python treats different types of numbers, how operators behave, and how parentheses give you control. By the end of this lesson, you'll read math in code as naturally as you read it on paper. Python works with whole numbers, decimals, and even complex numbers. You don't declare the type. Python figures it out from the value. Think of it like Python looking at the number and saying, "Got it. I know what you are." We now create an integer, a float, and a complex number. Then we print their types. Watch the output labels, int, float, and complex. That confirms how Python interprets each value. Math in Python works just like math on paper. Addition, subtraction, multiplication, division. Nothing new to learn. One thing to remember: some divisions return decimals, some return whole numbers only. Let's try these operators on the same pair of numbers. We will print one line per operation. Notice how back quote gives a decimal, back quote gives only the whole part, and back quote gives the leftover value, remainder. That's your mental map of math in Python. When an expression has many operators, Python follows math rules called precedence. Multiplication comes before addition, unless you override it. Parentheses are your remote control over the order. First expression, no parentheses. Python follows default precedence. Second expression, parentheses force addition before multiplication. Compare the results. The second one matches how you mentally group the numbers. Instead of writing x equals x plus 1 Python gives shortcuts. X plus equals 1 . These operators update the existing value. They are used in billing, counters, game scores. Everywhere values change over time. We start with a running total, then update it step by step using compound operators. As each line executes, notice how the value changes. This mirrors a growing bill or changing score. Python can compare numbers and ask logical questions like, is this more? Quote, are both conditions true? Comparisons return true or false. Logical operators combine those results. Let's compare two scores. Then combine conditions to check bonus eligibility. In the output, true and false appear based on the logic applied. Python has built-in helpers to simplify numeric work. No need for long formulas. Just call a function. Observe how each function transforms the value. In the output, absolute gives positive distance, round controls decimals, pow produces power, and max find extremes. Most bugs with numbers happen when mixing text and numeric values. Also, floating point values can show tiny rounding quirks. Knowing how to convert types avoids frustrating errors. First, we convert text digits to numbers and add them. Then, observe the floating point surprise. 0.1 plus 0.2 is not exactly 0.3 due to binary representation. Finally, rounding fixes the display. Time to apply what you learned. These tiny problems look like real tasks you will automate later. Pause and try each one before running the code. First, discount plus tax computation. In the output, observe the subtotal after discount and the final amount including tax. Temperature conversion, Celsius to Fahrenheit. Watch the output. The result appears as a float. Area of a circle equals *r. Simple formula, powerful result. Compare two marks and print the higher one. A perfect example of real-world decision making. Awesome work! You now understand how Python thinks about numbers. You learned numeric types, operators, precedence, how to convert and format, and solved practical mini problems in the next lesson. We introduce asterisk conditions so Python can make decisions. I'll leave the last 10 seconds for the end screen. If you enjoyed learning visually, please subscribe to Notebook Learnings so you never miss the next episode.